Hello everyone, this is Dr. Agalya. As we have seen how the blastocyst has formed and it has got implanted, now we are going to discuss how the further development of the blastocyst happens. Basically, I just want you to make clear this one, okay? So, we assume that a normal menstrual cycle of a female is around 28 days. If so, the ovulation will happen on the 14th day, right? And we assume that fertilization happens on this day of ovulation itself. So, if we consider, in embryology, we have three stages of fetal development, namely pre-embryonic stage, embryonic stage, and the fetal stage. So, this pre-embryonic stage lasts from 0 to 2 weeks. Embryonic stage lasts from 2 to 8 weeks, and fetal stage lasts from 8 weeks till birth. So, this is what we consider in embryology. So, basically, this will be considered as 0 week and the rest of the thing will be considered as 2 weeks. So, that is a pre-embryonic stage. Then comes embryonic stage and fetal stage. But what we are going to consider in obstetrics, basically what we see clinically, right? So, most of the times a woman comes to the clinic with her UPT positive or suspicious of pregnancy at her missed period only. So, basically she will come someday here, okay? But her conception will be taken from the last menstrual period, right? So, from here we will be taking. So, basically in obstetrics what we consider is it is the gestational age, but in obstetrics we consider something called as the gestational age. So, to find this gestational age, to the definitions of embryology, we will be adding 2 weeks prior. Okay, we will be considering plus 2 weeks. Okay. Now, we know this is the structure of the blastocyst, right? So, how is the structure of the blastocyst? So, basically it has an outer layer of cells, that is the trophoblast, and an inner cell mass, that is the embryoblast, and a blastocyst cavity which is containing fluid within, that is the blastocoele. Now, so blastocyst consists of inner cell mass and outer cell mass. Inner cell mass is going to become the fetus. Outer cell mass is going to become the placenta and the membranes. Now we will see how the further development of the inner cell mass will happen. In the inner cell mass, we will have 2 more types of cells forming the epiblast and the hypoblast. Epiblast is basically the columnar type of cells seen in the inner cell mass, and hypoblast or the cuboidal or the flattened cells seen in the inner cell mass. So, the inner cell mass will be dividing like this. Okay, so we have the columnar cells and we have the cuboidal or the flattened cells. Okay, so this is the epiblast, this is the hypoblast. Now, as this differentiation is taking place, already we know there is a outer layer of cells, right? So, that is the trophoblast, and inside we have now the epiblast and the hypoblast. Okay. So, the space between this epiblast and the trophoblast is now come to known as, it will be like a cavity, and this cavity will now be known as amniotic cavity. Okay. What happens is, then we know this is the hypoblast. So, cells from the hypoblast now starts forming inside this and form another layer that is adjacent to the trophoblast. Okay. So, basically we get another cavity here. Okay. So, how will be the final structure now? See, we will have the trophoblast, then we will have the epiblast, we will have the hypoblast. Here one cavity is already formed, that is the amniotic cavity, and then we have another layer of cells formed here from the hypoblast, right. So, basically if we name, this is the trophoblast, this is the amniotic cavity, so this is the epiblast, this is the hypoblast, and we have this new layer of cells that is formed from the hypoblast, and this layer is basically known as Hughes membrane, right. And this new cavity that is formed now will be known as the yolk sac. Understood? So, we will see this in a picture so that you will be able to understand it clear. Okay. So, this is for a better understanding. Okay. So, what are the things we see here? We have the trophoblast, that is the outermost layer. We have the epiblast, which are the columnar cells, and hypoblast, which are the flattened or the cuboidal cells. So, basically this hypoblast forms another layer of cells inside the trophoblast. So, that is known as the Hughes membrane. So, the cavity that is found between the trophoblast and the epiblast is known as the amniotic cavity, and the cavity that is found between the hypoblast and the trophoblast inside or the Hughes membrane is known as the yolk sac. Here we name it as primary yolk sac for now. Okay. Now what happens is, as this formation is over, another layer of cells, okay, is seen to be formed between the trophoblast and the Hughes membrane, and these cells are derived from the trophoblast. Okay. So, what's happening? It is the trophoblast, it is the trophoblast, we have the epiblast, we have the hypoblast, we have the amniotic cavity, primary yolk sac, and another layer of cells are deposited here, and this will be known as extra embryonic mesoderm, right? Now what happens is, inside this extra embryonic mesoderm, there are numerous small cavities will appear, and these cavities will fuse together to form extra embryonic coelom. Okay, so we have the trophoblast, we have the epiblast layer. For now I am drawing it just like a line. Okay, then we'll have the hypoblast. Okay, there is one more layer that is formed here, that is the extra embryonic coelom. Okay, now what happens is, there are numerous cavities that are forming inside this extra embryonic coelom. Okay, and all these cavities will fuse together to form the lacuna. Okay, so it will be like this. So it will be forming a huge lacuna. So this will be known as the extra embryonic coelom. Okay, after the formation of extra embryonic coelom, if we see the size of the yolk sac, okay, it has become very much smaller, right? Now this yolk sac will be called as secondary yolk sac. After the formation of the extra embryonic coelom, the yolk sac will be called as secondary yolk sac, since it has become very smaller in size. Okay, now we will see this in the pic, okay, for a better understanding. So we have, this is the extra embryonic coelom that has formed. Okay, so this is the extra embryonic coelom, and we'll have the yolk sac. Okay, then we'll have the amniotic cavity also. So what happens is, basically the extra embryonic coelom, it doesn't extend completely surrounding the yolk sac and the amniotic sac. There is one space where this extra embryonic mesoderm is left without forming a cavity. So this region basically forms the connecting stack. This connecting stack is going to become the future umbilical cord, right? Okay. Also, another change what is going to happen is, as the extra embryonic coelom is formed, the extra embryonic mesoderm is now split into two layers, namely the somatopleuric extra embryonic mesoderm and splanchnopluric extra embryonic mesoderm. So this is nothing but the parietal extra embryonic mesoderm, and this is nothing but the visceral extra embryonic mesoderm. Okay, so this is a final diagram to know about this. So we already have a extra embryonic coelom that has formed, so that the extra embryonic mesoderm is split into splanchnopluric and somatopleuric. Splanchnopluric mesoderm is nothing but the visceral extra embryonic mesoderm, and somatopleuric is the parietal extra embryonic mesoderm seen here. Okay, we have the amniotic cavity and the secondary yolk sac. Now, with the formation of this somatopleuric and splanchnopluric mesoderm, now we'll be able to identify the layers of chorion and amnion. These are the membranes. Okay, so chorion is nothing but the parietal extra embryonic mesoderm plus the trophoblast surrounding. Okay, whereas amnion is nothing but the visceral extraembryonic mesoderm and the amniogenic layer that is seen around the amniotic cavity. Okay, so these are the membranes formed. Okay, so just see this picture for a better understanding. So we have the chorion and the amnion, right? So chorion is formed by the parietal extraembryonic mesoderm and the trophoblast, and the amnion is formed by the amniogenic layer and the visceral extraembryonic mesoderm. Okay. Now what happens is, we have seen there is epiblast layer and the hypoblast, like this, right? What happens is, some of the cells of the hypoblast now become the columnar cells. Okay. So this is how it will become. After the formation of the procaudal plate, we will be able to identify the ventral and the dorsal aspects of the embryo as well as the caudal and the cranial ends. Okay. So this is basically the dorsal region of the embryo, and this is the ventral region of the embryo, and this is the cranial aspect of the embryo, and this is the caudal aspect of the embryo. Okay. After this formation, what happens is, in the epiblast also, there is proliferation of some of the cells. Okay. This is the procaudal plate, and here comes some of the proliferation of the epiblast cells also. Okay. Don't mind about my diagram, just for understanding I am doing like that. Okay. So this is the procaudal plate and this is the primitive streak. Okay. Now this primitive streak is very important because as primitive streak is formed, it marks gastrulation is going to begin. Okay. So what is gastrulation? Gastrulation is basically the formation of the layers. Okay. So what are the layers of the body? We have the endoderm, the mesoderm and the ectoderm, right? And basically this will happen at the 3rd week of gestational age. Now as the primitive streak is formed, one more layer of cells, okay, some of the proliferation cells, say some of the proliferated cells near the primitive streak will now start passing between the epiblast and the hypoblast. Okay, and this layer is now known as the intra-embryonic mesoderm. Okay, so remember the endoderm is formed from the epiblast. The mesoderm is formed from the intra-embryonic mesoderm, which we have already seen. It is coming from the primitive streak. Again, it is coming from the epiblast. The ectoderm is going to be formed from the epiblast more than the hypoblast. Okay. So finally, remember the concept that all 3 layers, okay, endoderm, mesoderm and ectoderm are derived from the epiblast. Okay. If you want to choose another best answer, then it can be the yolk sac. Okay. So this understanding is important. And what happens is, as this intra-embryonic mesoderm is passing between the epiblast and the hypoblast, this is not going to pass throughout the space. Okay, it doesn't pass through this procaudal plate as well as this primitive streak. Okay, so especially caudal to the primitive streak. Okay, so this area of procaudal plate where there is no intraembryonic mesoderm, only the ectoderm and the endoderm are going to lie in contact with each other, and this is going to become the future buccopharyngeal membrane. The same way, behind the primitive streak, where the ectoderm and endoderm are going to lie in contact with each other, this is in the cranial end. In the caudal end, that region is going to become the future cloaca. Understood? So, this is a picture for better understanding. So, we have the primitive streak. Behind the primitive streak, where the ectoderm and the endoderm are in contact with each other, so that is known as cloacal membrane. This is the cranial end where there is no intraembryonic mesoderm. So, that region is known as the buccopharyngeal membrane. Understood? Yes. Now, what we are going to see, so this is what happens with the inner cell mass. Now, what we are going to see is the changes that are taking place with the outer cell mass. In the outer cell mass, we have two different types of cells. Okay. Number one is the cytotrophoblast. Cytotrophoblast layer is also known as Langerhans layer. Basically, these are cuboidal to low columnar type of cells with single nucleus present inside. Okay. And another group of cells is the syncytiotrophoblast cells. Basically, these syncytiotrophoblast cells are derived from the cytotrophoblast cells only, and this layer can also be called as plasmoidal layer. Basically, this is the hormone factory for now. Okay. So, how are the cells of syncytiotrophoblast distributed? See, cells of syncytiotrophoblast, there are no defined cell borders and the nucleus are scattered like this, meaning they are multinucleated. Okay. Now, from the syncytiotrophoblast only, there is HCG production. Okay. Now, what happens is, as the syncytiotrophoblast is formed, this syncytiotrophoblast, say this is the cytotrophoblast layer and this is the syncytiotrophoblast layer and this is the uterine endometrium. Okay, as this is formed, now what is going to happen is, this whole mass is going to erode into the uterus, right? As it is going to erode, it is going to encounter the maternal capillaries, right? Now what happens is, this maternal capillaries become congested and dilated, and these will be known as sinusoids. As this syncytiotrophoblast is going to erode, there are formation of numerous lacunae. Okay, lacunae means numerous spaces inside the syncytiotrophoblast. So finally, a connection is established between these sinusoids and the lacunae, and thus the uteroplacental circulation is established. So basically, this uteroplacental circulation is established on day 15, Some books say is as day 12 also. Okay. Now these spaces, okay, where this connection has established, the spaces are known as intervillous spaces. Okay. So we'll see the diagrams now for better understanding. We have the outer syncytial trophoblast cells and the inner cytotrophoblast cells. Cytotrophoblast cells are single cells with a single nucleus, and the syncytial trophoblast cells are multinucleated cells and they don't have a defined cell border. Okay. So what happens is, from the chorion, this is the chorion, there occurs numerous villi, okay, surrounding the chorion. And as this is getting implanted, okay, so this is the decidua basalis layer. Another surrounding layer around the embryo is the decidua paritalis. So as this is getting formed, this region, okay, where as the villi are formed, the villi that is present nearer to the decidua paritalis will get compressed and this will disappear. Okay. So this region is known as chorion levae, whereas the villi in the decidua basalis, okay, are going to establish this connection between the fetal and maternal circulation, and this is known as chorion frondosum. Okay. So basically these two layers, okay, so that is the chorion frondosum and decidua basalis are together going to form the future placenta. Okay. For a better understanding, we'll see this pic. We have the decidua basalis. Okay. So the villi that is near to the decidua basalis in the chorion is known as chorion frondosum. Together these two layers are going to form the future placenta. We have the chorion levae in the nearby to the decidua capsularis. Okay. Now we'll see how the villi are now going to get established. Okay. So basically we have the villi. Okay. We have the villi like this, and then we have the intraembryonic mesoderm. Okay. So these are the villi, and these are the intervillous spaces, and also we have the intraembryonic mesoderm. We have the formation of villi happens in 3 stages, okay, namely the first stage is the primary villi, then it will become the secondary villi, and then it will become the tertiary villi. So what is primary villi? This is basically the cytotrophoblast surrounded by the syncytial trophoblast. Secondary villi is nothing but the cytotrophoblast plus syncytial trophoblast plus the intraembryonic mesoderm. What is tertiary villi? So basically this is the primary villi where we have the cytotrophoblast and the syncytial trophoblast like this. Okay. So during the formation of the secondary villi, this intraembryonic mesoderm also comes like this. This is secondary villi. And what happens with the tertiary villi is that you will have cytotrophoblast, all the same like secondary villi, okay, cytotrophoblast, syncytiotrophoblast, this intra-embryonic mesoderm, and now what happens is the fetal arteries also come in between, okay. So basically it is like this is the intra-embryonic mesoderm, okay, and the fetal arteries also come like this, okay. So these are the tertiary villi, okay. So with this picture you will be able to understand what we have discussed till now, okay. Basically we have the syncytiotrophoblast here, this is the cytotrophoblast, and this is the extra-embryonic mesoderm. This is the primary chorionic villus, okay. Here we see that the extra-embryonic mesoderm is not invading the cytotrophoblast, whereas in the secondary chorionic villus you are able to see that this extra-embryonic mesoderm is going inside the cytotrophoblast, and in the tertiary chorionic villus there comes arteries also, okay, that is invading the extra-embryonic mesoderm, okay. Now this trophoblast, cytotrophoblast, we have already seen it is going to become the syncytiotrophoblast as well as the villus trophoblast. Some of the other cells of the extravillus of the cytotrophoblast is also known as extravillus trophoblast. From the extravillus trophoblast, we will have the interstitial extravillus trophoblast, endovascular extravillus trophoblast, and endoglandular extravillus trophoblast. So, interstitial extravillus trophoblast or the trophoblast that will help in anchoring the placenta to the uterine endometrium. Endovascular trophoblasts or the trophoblasts which are going to invade the spiral arteries. As they invade the spiral arteries, these spiral arteries will now become low resistance vessels, so that there will be no hindrance in the blood supply to the fetus. Next comes the endoglandular trophoblasts which are going to invade into the uterine glands, okay. So if you see this picture you will be able to understand. So we have three types of trophoblast as we have discussed. One is the interstitial trophoblast over here that is going to invade the uterine endometrium, and endovascular trophoblasts which are going to invade the spiral arteries, and finally the endoglandular trophoblast which is going to invade the uterine glands, okay. So this is the final picture. So basically this is how it is going to happen. Basically there is fertilization, then comes the blastocyst, okay, then comes the where we will be able to see the trophoectoderm and inner cell mass. So with this picture you will be able to understand the whole process. So first there is fertilization, and then there is a formation of the blastocyst which is going to get implanted in the uterine endometrium, okay. So there is lacunae which is the cavities that are formed in the syncytiotrophoblast, and the maternal blood sinusoids was nothing but the maternal arteries that have dilated and congested, and as this is getting invaded, you will have the formation of the primary villi. Also you will be able to see the various types of trophoblast that has formed: interstitial trophoblast, endovascular trophoblast, and some of the trophoblasts will be invading the uterine glands also, that is known as endoglandular trophoblast. Some of the points I want to add here. So far we have discussed about the pre-embryonic stage and embryonic stage. So there is something called as all or none effect, okay. So basically during this period, if there is a teratogen exposure, any kind of teratogen, maybe our infection or radiology exposure or any drugs, what happens is, during this period, especially up to 35 days of intrauterine life, either there will be nothing to the embryo, no effect on the embryo, and the embryo will survive, or the embryo won't continue the further development and it will die in utero. Okay? So, this is the point I wanted to add. So, I hope you'd have got the basics of what is gastrulation, what are the layers from which it is derived, what is yolk sac, what is amniotic cavity, what are the membranes, like what is chorion, what is amnion, and how the formation of placenta is going to happen. So, with this, we'll finish this video. Until we meet in the next video, take care and bye-bye.